everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम लोग कंप्यूटर नेटवर्क की क्लास करेंगे जो कि कंप्यूटर नेटवर्क की क्लास 10 है। ऑलरेडी हमने 9 क्लासेस कर लिया है जिसमें हमने यूनिट 1, यूनिट 2 एंड यूनिट 3 हम ऑलरेडी कंप्लीट कर चुके हैं। एंड आज जो हम स्टार्ट करेंगे वो यूनिट 4 स्टार्ट करेंगे जो कि ट्रांसपोर्ट लेयर है। यूनिट 3 आपकी नेटवर्क लेयर थी, यूनिट 2 आपकी जो लेयर थी दैट इज़ योर सब लेयर, that is the first unit is your introduction to computer network. So that what we had discussed about it and we had completed as well. And now in this class, in the 10th class, we'll start with transport layer. And first of all, it's a huge request from my side to all of you, please go through with the subscribe button and please like, share and subscribe to our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the terms of the transport layer, if I'm talking about, so in the transport layer you have to understood about the transport layer or their design issues. So the transport layer design issues that you have to discuss about it, and here first we'll start the question that is what are the duties of transport layer. So first we'll discuss about the duties of transport layer. In the terms of the duties of the transport layer, that what we have to discuss, that is related to the transport layer design issues and the duties that you have to conclude it here. In the terms of that is the transport layer, the duties of the transport layer here, that the duties, or they can ask you about the functions of transport layer as well. Function of transport layer. So the duties of transport layer or functions of transport layer, that is same. So first is that the layer breaks message into the packet and it performs error recovery if the lower layer are not adequately error free. The third is that the function of the flow control if not done adequately at the network layer, and the fourth is that the function of multiplexing and demultiplexing sessions together, and the fifth is this layer can be responsible for setting up and releasing the connections across the network here. These were the 5 functions and the duties of a transport layer. In the terms of it related to the transport layer, that what we have to know about it, in the transport layer protocol provides for logical communication between the application processes running on a different host, and the logical communication means that the communicating application processes are not physically connected to each other from the application's viewpoint, and even though the application processes use the logical communication provided by the transport layer to send message to each other, where the transport layer protocol are implemented in the end system but not in the network routers, and the network routers only act on the network layer field. All transport layer protocol provide an application multiplexing, demultiplexing services as well. In the same case, the transport layer is responsible for the reliable data delivery. The upper layer protocol depends heavily on the transport layer protocol, and a high level of error recovery is also provided by this layer, and a layer that ensures the packet and that delivered error free in the sequence and with no losses or duplication as well. Where in the same case, now we'll discuss about the various protocols giving their significance at the transport layer, or we can say that the transport layer protocols, that is Tcp and Udp. Transport layer protocols, that is Tcp and Udp. So in this, the transport layer protocols, there we will have to discuss about the Tcp and the Udp, where the full form of Udp is the user datagram protocol, and is a connectionless protocol where Udp is used for the application that requires a quick but necessary reliable delivery. Udp uses the port numbers and an addressing mechanism in the transport layer. With the same case of the Udp here, that Udp is a connectionless protocol, provides no reliability or a flow control mechanism. It also has no error recovery procedures as well. The several application layer protocols such as TFTP, which is the full form of Trivial File Transfer Protocol, TFTP. So in the TFTP here, that is Trivial File Transfer Protocol. So trivial file transfer protocol here. In the same case with this and RPC and the UDP. The UDP makes use of the port concept and the direct diagram, that as datagram to the proper upper layer application, and UDP serves as a simple application interface to the IP as well. The UDP checksum is end-to-end checksum, and it is calculated by the sender and then verified by the receiver, and it is designed to catch any modification of the UDP header or the data anywhere between the sender and as well as the receiver as well. Talking about the TCP here with the same request, that is TCP provides a connection oriented reliable byte stream services, and the term connection oriented means that the two applications using the TCP must establish a TCP connection with each other before they can exchange the data. Where the TCP here, that the TCP provides a connection oriented reliable byte stream services, as TCP does not interpret the content of the byte at all, and the TCP has no idea if the data bytes being exchanged are binary data, ASCII characters, or any other. If the application on one end writes 20 bytes followed by a write of 40 bytes and followed by a write of 80 bytes, the application of the other end of the connection cannot tell that what size the individual writes there. The other end may read 140 bytes once at a time, or 140 bytes in two reads of 70 bytes at a time here. With the same reference towards it, that the TCP also provides flow control. Each end of the TCP connection has a finite amount of buffer space, and a receiving TCP only allow the other end to send as much data as the receiver has buffer for, and this prevents a fast host from taking all the buffers on the slower host as well. Now we'll discuss the various QoS, that is quality of services primitive, looked for the transport layer here. Now we'll discuss about the various QoS, that is the various quality of services. QoS, that is, you can say that is your quality of services. That is the primitive looked for the transport layer, that has also been asked of 10 marks. So that what we'll discuss here. In that QoS, if I'm talking about, there are many things to related to that is quality of services, that the transport protocol entity should allow the transport services user to specify the quality of transmission service to be provided, and the user may specify the quality of services parameter at a transport layer, and at a connection that setup time, user may define the preferred acceptable and minimum value for the various service parameter as well. The transport layer determines whether it's possible to provide required services based on available network services, and following the transport layer quality of services parameter, there are 5 parameters that we deal with it. And the first we have error and loss level. Error and loss levels. The second we have desired average and maximum delays. The third we have is your throughput. The fourth is your priority level, and the fifth we have is your resilience. These were the 5 parameters of the transport layer quality of services parameters here, and the error and the loss of levels that here that measures the number of the lost and or garb, that is your garbed message as a fraction of the total sent, and where that the desired average and the maximum delay measures the time between a message being sent by the transport user on the source machine and it's being received by the transport user on the destination machine, and where the throughput here that the throughput parameter measures the number of the bytes of the user data that is transferred per second measured over some time of interval, and the priority level that parameter provides a way for a transport user to indicate that some of its connections are more important than other ones and the high priority connections get serviced before the low priority ones here. In that the connection established delay is that time to establish connection, and the connection established failure probability is that the probability connection to not established within the maximum establishment time as well. In the reference towards the throughput, that is the bytes transfer per second that is measured over a time interval here. In that same case, the transit delay is that a time between sending a message and receiving it on the other side that is measured by the transport entity. And the residual error ratio that we have here is that the ratio of the message in the error to the total message sent. Whereas talking about the priority here, in the priority that a way for user to indicate that some connections are more important, and in the terms of resilience that the probability connection is terminated due to the congestions etc., that is known as resilience here. Let's go ahead further, and that we will discuss about the elements of transport protocol. And in the terms of the elements of transport protocol, the question has been asked of 10 marks, that is, how does the transport layer ensures that the complete message arrives at the destination and in the proper order? That is reference towards the elements of transport layer protocol. In the same case, they had asked you how does the transport layer ensures that a complete message arrive at the destination and the proper in a proper order. With the same regard of it, we'll have to discuss about it, and that is that the transport services is implemented by the transport protocol that is used between the two transport entities, and at the data link layer, that is the two routers communicate directly by a physical channel, and whereas the transport layer physical channel is replaced by the entire subnet as well. For the router in the data link layer, not necessary to specify which router it wants to talk to, but in the transport layer, the explicit addressing of the destination is required here. In the order for the two hosts to communicate using the TCP, they must first establish a connection by exchanging the message in what is known as the three-way handshake, and when the host A receives the host B ISN and acknowledgement, and it finishes the connection establishment phase by sending a final acknowledgement segment to the host B, and in this case the host A sets the acknowledgement control bit and indicates the next expected byte from the host B by placing acknowledgement number, that is Y+1, in the acknowledgement field here. Once ISNs have been exchanged, communicating applications that can transmit the data between each other, and SEQ, that is the sequence number, is used to keep the track of the data packets being transferred from host A to host B, where a synchronized acknowledgement packet is sent back to the host, and the acknowledgement is an acknowledgement that host B receives the packet from host A, and there is a number attached to the acknowledgement with the value of x+1, and where the x is a that is the x is the sequence number that should be the sum of the sequence hash from the packet 1 and plus then the length of the packet 1 as well. In the same case, the TCP assigns the sequence number to each byte that transmitted and expects a positive acknowledgement from the receiving TCP, and if the acknowledgement is not received within the timeout interval, the data is retransmitted. Since data is transmitted in the blocks, that is TCP segments, only the sequence number of the first data bytes in the segment is sent to the destination host, where the receiving TCP uses the sequence number to rearrange the segments when they arrive out of the order and to eliminate a duplicate segment as well. With the same case, if I'm talking about here, that is that the receiving the TCP here, when sending an acknowledgement back to the sender, and also indicates to the sender the number of the bytes it can receive beyond the last received TCP segment without causing the overrun and overflow in its internal buffers, and this is sent to the acknowledgement in the form of the highest sequence number, and it can receive without problem, and this mechanism is also referred to as a window mechanism here. Let's go ahead with a further one that what we have to discuss the transport services primitives, and what do you understand by the term that is the way handshake, and explain the problem which is solved by this 3 with a handshake as well. So we'll go ahead with this. That has been asked of 10 marks as well. That is transport service primitives. So the transport service primitives here, in the transport service primitives, that to allow the user to access the transport services, and the transport layer must provide some operations to application program where the real networks can lose packets, so that the network services is generally unreliable and the transport services is reliable here, and where the network services is used only by the transport entities, and the transport services must be convenient and easy to use as well. So following are the primitives that is used for a simple transport services. So we'll discuss about the primitive, that is the package, and of course the meaning here. That is primitive. Then we have a packet sent, and then we have meaning. So the first primitive we have is listen. Here this primitive is the packet sent is none, and meaning is block until some process tries to connect. The next primitive we have is your connect. In the connect, that the packet sent is the connection request, that is connection REQ. The meaning is that actively attempt to establish a connection here. For the primitive is sent, and packet sent, that is your data, and where the meaning is send information. The next is your receive. For the packet sent is none, and here that is block until a data packet arrives here. The another we have here, that is the last as well, that is your disconnect. The disconnect, that is disconnect REQ. And in this, the site wants to release for the connection here. So this is a sort of a table that you have to make. Okay, so here in this, with the reference toward the client connect call causes a connection request, that is your TPDU to be sent to the server. So when it arrives, the transport entity that checks to see that the server is blocked on the listen, and it then unblocks the server and send the connection accepted TPDU. where back to the client, and where this TPDU arrives that the client is unblocked and the connection established. That TPDU stands for the Transition Protocol Data Unit, where that the data can be exchanged using the send and receive primitives, and when the transition protocol data unit arrives, the receiver is unblocked and it then processes the transition protocol data unit and send a reply. When a connection is no longer needed, it must be released to free up table space within the two transport entities. That this connection has two types, asymmetric and symmetric here. Now we'll discuss about the three-way handshake. Three-way handshake. In the three-way handshake, here it is host A, this is host B. This is with respect to time. Here it is send synchronization sequence equals to X. This has been sent to host B in the network. Here receive SYN. Then this is send SYN sequence equals to Y, and where acknowledgement X plus 1. So then we receive sync plus 1 acknowledgement here, that is, and then after that we will be having this, that is received. This has been sent like that is just sent acknowledgement Y plus 1, and that has been received acknowledgement here. So this is with respect towards it, that it can be seen here. With the three-way handshake, there are the three phases in any virtual connection, and they are the connection establishment, data transfer, and connection termination phase. In order for the two hosts to communicate with the TCP, they must first establish a connection by exchanging the message in what is known as three-way handshake, where the process of three-way handshake has been represented, that it can be seen that there are the three TCP segments exchange between the two hosts, that is the host A and the host B. And to start a host A, that initiates the connection by sending a TCP segment with the sync control, a bit set, and an initial sequence number, and have here it is represented as the variable X in the sequence number field here as well. With the same case, if I'm talking about that at some moment later in time, host B receive in the sync segment, and that the process set and response with a TCP segment of its own. The response from the host B contain the sync control bit set and its own ISN, not represented as a variable Y here. With regard of it, the host B that also sets the acknowledgement control bit to indicate the next expected byte from the host A, that should contain data starting with the sequence number X plus 1. And even though when a host A receives the host B ISN and acknowledgement, it finishes the connection establishment of host B, and in the case of the host A, set the acknowledgement control bit and indicates the next expected byte for the host B, that placing the acknowledgement number Y plus 1, and that is the acknowledgement field here. In the same case, that once the ISN have been exchanged, the communicating application can transmit the data between each other. Let's go ahead with the discussing about explain the upward and downward multiplexing in the transport layer here. So let's go ahead to discuss about it. With this, I will discuss first of all upward and downward multiplexing. So up in transport layer. So upward and downward multiplexing in a transport layer. First we'll understood about multiplexing, then we'll discuss about the upward and the downward as well. With the same regard of a multiplexing, the many virtual circuit where in the same case that we can say that many virtual circuits open for a long period of time and is to make the multiplexing of the different transport connections onto the same network and the connection attractive. This form of multiplexing called the upward multiplexing, and for that the four distinct transport that the connections all uses the same network connection and to the remote host, that the transport layer forms a group of the transport connection according to their destination and map each group onto the minimum number of the network connections here. So many transport connections that are mapped onto a one network connection, the performance will be poor, and because the user have to wait their turn to send one message. If too few or transport connections are mapped onto one network connection, the service will be expensive. The transport layer opens the multiple network connections and distributes the traffic among them on the round-robin basis. This is called downward multiplexing here. In accordance of that, that when the K networks network connections open, the effective bandwidth is increased by the factor of K, and if multiple output lines are available, downward multiplexing that can also be used to increase the performance even more, and that is showing the representation of multiplexing. So we'll go ahead with the figure where we'll discuss about the upward multiplexing and the downward multiplexing. That makes you clear as well. Here we'll discuss about it, that is your the upward multiplexing. This is layer 1, 2, 3 and 4. These were the layer, and here it is 2, 3 and 4, and then we have again here these were connected to one another. So this is to a router, and these were your, that is transport address, and this is known as upward multiplexing. Now talking about the downward multiplexing here. Layer 1, layer 2, layer 3, layer 4 as well. This is to router layer. This is connected to one another, and these were known as network address. Okay, so this is comes under known as downward multiplexing, that it will be talked about it. Okay, so this were the two, upward multiplexing and the downward multiplexing. Let's go ahead with the discuss explain the transport layer crash recovery. Crash recovery of transport layer. In this, that if the host computer, server, router are subject to crashes, and the recovery from these crashes makes some problem. If the network layer provides a connection oriented services, then the loss of the data or the virtual circuit is handled by the establishing a new connection, and then retransmit retransmit the TPDUs which has not received, and if the host server crashes, then the client must quickly reboot here. In the same case, when the server crashes and while receiving the data from the client, the outstanding TPDU is lost, and to recover the data when the server comes back up and its tables are reinitialized, so it no longer knows precisely where it was, and the server might send a broadcast TPDU to all other hosts, announcing that it has just crashed and requesting that its client inform it and for the status of all open connections, that to client that the client that can be in of one of the two states, that is TPDU outstanding or the no TPDU outstanding. Based on only this state information, that the client must decide whether or not to retransmit the most recent TPDU as well. To avoid the duplicate of the data, the client should retransmit only if it has an unacknowledgement TPDU outstanding. And there are many situations for crash recovery. If the server send acknowledge and crash the server before writing the data, the writing, saving data, and sending the acknowledgement, both are different process, so that the server and the client program in any way the loss of the data and duplicate the data may occur. If both sides are programmed considering all situation up to some limit, it is possible to recover the lost data and possible to avoid retransmitting as well. With the same case, now we'll discuss about the UDP, that is user datagram protocol, where we have to discuss what is UDP and what is the maximum and minimum size of the UDP datagram, and also discuss the use of the UDP as well. That has been asked of 10 marks. So we'll go ahead with the detail of the UDP. That stands for user datagram. And with the user datagram here, that we have with the same reference towards it, like maximum and minimum size of the UDP datagram, and then of course the use of UDP, that what we have to discuss here. In the same case here, where the UDP is a simple datagram oriented transport layer protocol, and this protocol is used in the place of TCP as well. And UDP is a connectionless protocol that provides no reliability or a flow control mechanism. It also has no error recovery procedures, and UDP makes the use of the port concept to the direct the data graph to the proper upper layer application, and the UDP serves as a simple application interface to the IP as well. And that the format of the Rtp header, the port number identifies the sending process and receiving process as well. So for that sake, we will discuss about the UDP here. That in the same case, source port number equals to 16-bit, destination port number that is equals to 16-bit. This is of 8-byte. Okay, and this is another last is your data optional. Starting with 0 to 31. This is UDP length, which is 16-bit, and this is UDP checksum, that is equals to 16-bit. With the minimum length of the 8-byte, because of that it is the length of the header, and the field size sets But in the same case, that UDP is a simple datagram oriented transport layer protocol, and the protocol is used to place the TCP as well. With the same, the format of the UDP header, the port number that identifies the sending process and receiving process as well. The minimum length of the 8 bytes, that is, because it has the length of the header, the field size that's at theoretically limit of 65,535 bytes, an 8 byte header plus 65,527 bytes of the data for the UDP datagram here. The practical limit for the data length, which is imposed by the underlying IPv4 protocol, is 65,507 bytes, which is equals to 65,535 minus 8 byte UDP header and minus 2 bytes IP header as well. The UDP checksum covers the UDP header and the UDP data, and both the UDP and the TCP include a 12-byte pseudo header with the UDP datagram just for the checksum computations here, and that the pseudo headers include the certain fields from the IP header, and this purpose to let the UDP double check that the data has arrived at the correct destination as well. With the same case, that UDP checksum is end-to-end checksum, and it is calculated by the sender and they are verified by the receiver. It is designed to catch any modification of the UDP header and the data and anywhere between the sender and the receiver. Or you can say that the redundancy check or the detect error as well. Talking about the application of UDP, application of UDP. In the case of the application of UDP, there are the three applications. The first is that UDP is used for some route updating protocols such as Rtp, and UDP is used for multicasting, and it is suitable for the process with internal flow and the error control mechanism as well. Where in this they had asked you about explain the protocol of the transport layer designed for the multimedia application, and what is socket, explain, that has been asked of 4 marks, and what is the socket address, explain, that has been asked of 4 marks and 5 marks here. So in that we will be having that is your socket. We will discuss about socket. In the socket here, that the clients and the servers establish a connections and communicate via socket. The socket are the endpoint of the internet communication, and the connections are the communication link that are created over the internet using TCP, and some client server application are also built around the connection length UDP, and these application also use the socket to communicate, and client create client socket and connect them to the server socket as well. So the sockets are associated with the host address and the port address, and the host address is the IP addresses of the host where the client and the server program is loaded, and the port address is the communication port used by the client or the server program, that the server program use is well known for the port number associated with their application protocol, where a client communicate with the server by the establish of the connection to the socket of the server, and the client and the server then exchange the data over the connection here. Before an application program that can be transfer any data, it must first create an endpoint to communicate by calling socket, and the socket facilities are provided in the C language that to be used. These facilities, the header files, that is types.h or and the socket.h, must be included in the program. In the prototype is that int socket, int family, int type, int protocol, where the family identifies the family by the address of the protocol, and the address family identifies a collection of protocol with the same address format, and while the protocol family identifies the collection of protocol having the same architecture. The type identifies the semantics of the communication, where the sock stream is one type and that provides the data delivery services as a sequence of bytes and does not preserve message boundaries, and the protocol identifies the specific protocol that to be used as well. In the same case, if I'm talking about more detail about it, that normally one protocol is available for each family and type, so that the value for the protocol argument is usually set to 0, that to indicate the default protocol as well. And after the socket is created, the blind bind system that calls that can be used to assign an address to the socket, and the prototype is like in that case in the blind way, that is int bind int sd structure, that is struct address name int name length, where the here that is the SD is a socket descriptor and returned by the socket call, and name is a pointer to an address structure that contains the local IP address and a port number, and the nameless is the size of the address structure in in bytes as well, and the bind system that calls 0 on success and -1 that is on failure here. So now I'll discuss about what is the real-time transport protocol and draw the header format for the RTP and explain the field as well. So real-time transport protocol, which we have to discuss here. Real-time transport protocol, which stands for RTP here. In this, the real-time transport protocol that run over the user datagram protocol, and the real-time protocol that is used for the multimedia application, video conferencing, music on demand, video on demand, audio, video, and text, and the content of the multimedia. Multimedia application also contains other types of the data streams, and all these data is stored into the RTP library in the user space along with the application. The library then multiplexes the streams and encodes them in the RTP packets, which then stuffs into a socket as well, that the RTP header we have here, which is named as so here it is. It is in the same site. This is 31, this is 0, this is 32-bit, with this we have here that is your 2 bits version, then P that is of 1 bit, then X that is of 1 bit, then we have C that is 4 bit, then that is we have M 1 bit, payload type 7 bits, then sequence number that is 16 bit. Okay, so this is, and then we have a time span, then we have time stamp that is of 30 bit, 32 bit. This is your synchronization source identifier, 32 bits, and then we have here in the show that is your contributing source identifier. And for that, this is your Rtp header. Here with this, that real-time transport protocol that run over the user datagram protocol, and the real-time protocol used in multimedia applications and video conferencing and music on demand, video on demand, audio, video and text, and the content of the media as well. The multimedia application also contain the other types of the data stream, and all these data is stored into the Rtp library in the user space along with the application, and this library then multiplexes the stream and encodes them in the Rtp packets, which then stuffs into that is socket, that the Rtp header we have. With the same reference to the Rtp here, that the Rtp header size is 32 bits, and fields in the header of that is your P, A, and X and CC, that is that payload and sequence number, timestamp, synchronization, source identifier, and contributing the source identifier as well. So where that the version, the size of the version field is 2 bits, and it indicates a version number, the current version is 2. And p bit, that is the size of 1 bit, and p bit indicates that the packet has been paddled multiple 4 bytes, and the x bit size is here, and that is again 1 bit, and it indicates that the extension header is present, where in the cc field, this is the size of the cc field is 4 bytes, and cc field is used in indicating the numbers of the source present, and the range is from 0 to 15 here, where in the case of m bit, that is the marker bit is of 1 bit size, and the bit is used to indicate the start of the frame, and it may be a video frame, start of the word in an audio channel as well. With the same case, the payload type, that the size of the payload type field is 7 bit, and the field is used for indicating the encoding algorithm and has been used. It determines its interpretations by the application. We are talking about the sequence number here, that is, this is the 16-bit field is incremented by one of the each of an Rtp packet is sent, and the number that can use to receive the detect packet loss and to recover the packet sequence, the initial value is selected at random. Talking about the time span here, as you can see, it is of 32 bits. Number specified that sampling instance of the first byte in the Rtp data packet, and this value can help to reduce the jitter at receive by decoupling the playback from the packet arrival time, and the initial is initial value is selected at random. This next is your synchronization source identifier. With this field tells which stream that the packet belongs to, and it is a method used to multiplex and demultiplex multiple data streams onto a single stream of UDP packet as well. Talking about the next one, that is your contributing source identifier. This is the list of 0 to 15 here, and in the same case for the 0 to 15, 32 bit items specifies on contributing source. So for that, the payload contained in the packet, and that field is used when the mixers are present in the studio as well. So this is what we have to discuss here. Now we'll go ahead with the TCP here, and in the TCP, where we have to draw a diagram for the TCP header and explain all the use of the following source destination, even though the ports source as well, and with the regard of the source destination as well, so that we will discuss here. And before that, we will go ahead with the another one, that is the differences between the TCP and UDP, which is very important and that has been asked for many times. So first we'll discuss and we first will compare the contrast between the TCP and RTP, and are both doing the same thing, that we will discuss. Then we will discuss the differences that has been asked of 10 marks, and then after that we'll discuss TCP and UDP as well. So let's go ahead here. Difference between TCP and RTP. In the TCP and RTP here, that we have that has been asked of 10 marks, so that is you have to go ahead along. And for the RTP and the TCP, starting with the that is from RTP, that is the RTP has no flow control, and for TCP has a flow here. And for RTP does not support error control, but TCP error control support error control. RTP has no acknowledgement and no mechanism to request a retransmission, and where the TCP provides acknowledgement and retransmission, where RTP header has 32-bit header and TCP has 32-bit header as well. With the RTP a 16-bit sequence number, but the TCP the 32-bit sequence number is available. So this is what in the terms of it we are talking about RTP. The real-time protocol is used in multimedia application, video conferencing, music on demand, video on demand, audio, video and text of the content of the multimedia, where RTP uses the user space and link with the application program so that it look like an application protocol, and RTP is a generic and application independent protocol as well, where the RTP handles the real-time data streams onto a single streams of UDP packet, where in terms of TCP, that TCP provide a connection oriented reliable byte stream services. And this term the term connection oriented means that the two applications using the TCP must establish a TCP connection with each other before they exchange the data here. In the regard of it, let's go ahead to explain about the TCP header and a working of TCP protocol, and differentiate between the TCP and the UDP with the frame format. And same for the another thing, that the TCP header of the working of TCP protocol we had discussed about it, and the frame format TCP UDP we had discussed about it. So let's go ahead for the difference between TCP and UDP. So if the difference between the TCP and UDP here, that is the first differences of TCP here, that is TCP is a connection oriented, where the UDP UDP we have, that is UDP is a connectionless here. The TCP connection is a byte stream and a UDP connection is a message stream. TCP does not support multicasting and broadcasting, and where UDP support broadcasting. It provides error control and flow control, and it does not provide flow control and error control. TCP supports full duplex transmission, where UDP does not support full duplex transmission. TCP is reliable, UDP is unreliable. TCP packet is called segment and UDP packet is called the user datagram. These were the 7 differences which you have to answer when you are gone through with that question, because this has been asked for that is of 10 marks, so that is very important in the terms of it. And as of we'll go further here with the detail, that is there are many things to discuss in the terms of the TCP, and of course in the difference towards your UDP as well, and with the regard of it we have to discuss about many of the questions as well. So let's go ahead to discuss about some of the possible questions that they had asked you about in the terms of that is the short answer questions, that what we'll discuss here. And in the same case, first of all, it's a huge request to all of you, please go through with the subscribe button and please like, share and subscribe our channel. Let's go ahead with the short answer question that has been asked many times in the examination paper, and which were possible questions that we have to gone through with that. The first question they can ask you is in the sum that a typical socket application that responds towards the one that is here. And that will be help to discuss about session layer design issues. The session layer design issues when we have to discuss here, in that they had asked you about 10 marks, that is explain how the session layer establishes, maintain and synchronize the interaction between the two communicating hosts, and with the same reference towards it that they had asked you about 10 marks here. In the session layer design issues, the session layer resides above the transport layer and provides the value-added services to the underlying transport layer services, and the session layer adds services to the transport layer that are likely to be of the use of application, and so that each application does not have to provide its own implementation as well. That the session layer deals with allowing users to establish the communication session between the different machines. Design issues include the first that it includes is managing dialog control. In the managing dialog control, that the traffic can go in both direction at the same time or in one direction at a time here. The second we have here is your that is token management. In the token management, that both sides do not attempt the same operation at the same time. The third is your synchronization. In the synchronization, the insertions of the checkpoints to determine the portions of the transmission here. Talking about the session layer, provide that the following services. So on the basis of the services, we have three. So we have three. The first we have is your that is dialog management. In the dialog management, that deciding who turn it is, and some application operate in a half duplex mode, whereby the two sides alternate between the sending and receiving messages and never send data simultaneously. In the ISO protocol, the dialog management is implemented through the use of the data token, and the token is sent back and forth, and the user may transmit only when it possesses the token here. The second we have your synchronization. In the synchronization, move the two sessions entities into the known state here, and that is comes under the transport layer handles only the communication error. Synchronization deals with upper layer errors, and in a file transfer, for instance, that the transport layer might deliver the data correctly, but the application layer might be unable to write the file because the file system is full, and the user can spread the data streams into the pages. Inserting the synchronization point between each page. When an error occurs, the receivers that can synchronize and the state of the session to previous synchronization point, even though, and this required that the sender holds the data as long as may needed. And synchronization is achieved through the use of the sequence number, where the ISO protocol provides both major and minor synchronization point. In addition, major synchronization points are acknowledged through explicit message, and in contrast, minor synchronization points are just the markers here. So with the same case, the third one we have here is your activity management, where the activity management that allows the user to delimit the data into the logical unit that is called activities here, and each activity is independent of the activities that come before and after it, and an activity that can processed on its own. The activity might be used that delimits files of multiple file transfer as well. With the same case, if I'm talking about many more things that will be discussed, and that is we have to discuss many more things as we had talked about the block ciphers and of course the plain ciphers as well. And with the why there are UDP, that is for the no connection establishment, which can add delay, and simple, that is no connection state, and the sender receivers, the small segments header, and no congestions control, that is UTP, can blast away as fast as desired, of course. With the same case, we'll go ahead with the another thing that what we have to discuss, that is what is leaky bucket. As I told you about many times, a leaky bucket is a traffic shaping mechanism. In a leaky bucket, the input rate can that can vary, but the output rate remains the constant, and a technique called as leaky bucket that can smooth and busty traffic as well. With the same going ahead, we will be have to discuss about that is the differences, and in the same case what are the differences between the congestions control and the flow control, that what we have to discuss. So the flow control is done by the servo machine, where the congestion control is done by the router, and the flow control cannot block the bandwidth of the medium, where the congestion control block the bandwidth of the medium as well. And the flow control affect less of the network performances, and congestion control affect the network performances. And flow control was uses a buffering, whereas the congestion control not use buffering. So these were the things that we have to use it at all, and that is the approaches to improve that is the quality of services that we have to discuss. With the same case that the first approach is that fine grained approaches, which that provides the quality of services to the individual application of flows, that is integrated services, a quality of services architecture developed in the IETF and often associated with RSVP. And the coarse grained approaches that which provide the quality of services to larger classes of the data or aggregated traffic, that is differentiated services, which is probably the most widely deployed quality of services mechanism as well. As we are talking about the quality of services, first you have to know about what is the quality of services here. Where in the term of what do you mean by the QoS? That is, the quality of services is used in some organization to help provide an optimal end user experiences for audio and video communication. That the quality of services is the most commonly used on network where bandwidth is limited and with a large number of the network packet that is competing for the relatively small amount of available bandwidth. Now we'll go ahead, we'll end up with this class. And first of all, it's a huge request from my side to all of you, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. We had completed the unit 1, that is your introduction concept, which is your goals and applications of network structures and architecture, the OSI reference model services, network topology design, delay analysis, backbone design, local area network design, physical layer transmission media, switching method, ISDN, terminal handling as well. This unit 2, we have a medium access sublayer, that is a medium access sublayer of channel allocation, LAN protocol, Aloha protocol, overview of IEEE standard, every DDI, data link layer, elementary data link layer, sliding window protocol, error handling. The unit 3 we had completed, that is your transport layer, network, that is your network layer, that is the point-to-point network layer, and that is of routing, congestions control, inter-networking, TCP IP packets, IP address and IPv6. Now we had started with unit 4, that is your transport layer, which we have discussed about transport layer, design issues, connection management, session layers, design issues, remote procedure call, presentation layer, design issues, data compression technique, cryptography, TCP, that is window management. In unit 5, we have to complete application layer, that is application layer, file transfer, access and management, electronic mail, virtual terminals, other application, example networks, internet and a public network. That what we have to cover up in the next coming classes. So first of all, let's a huge request from my side to all of you, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. You will be provided all the videos on your playlist. You can go through with the playlist, you will be getting all the videos there with reference towards the computer network, artificial intelligence and reasoning that we had done. We are going to learn that, and that is reasoning में भी हम already non-verbal reasoning complete कर चुके हैं, verbal reasoning complete कर चुके हैं, non-verbal reasoning में हम series topic कर रहे हैं जिसमें हमें already more than 1000 questions करने हैं. So you can go through with that, you will be finding out each and every video here. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give us suggestion on the comment box. Thank you.